Hey, what's up guys? Today we'll be doing hypothesis testing. Now before I start with hypothesis testing, I just want to let you know that I would have expected you to have done hypothesis testing in school a little bit so that you actually know what's happening, because if you don't know what's hypothesis testing and you listen throughout this whole video, you will feel lost like an alien. So seriously, you have to read up a little bit first and you can watch this video. I'm just saying, but if you still want to go ahead, it's up to you. Alright, so for hypothesis testing, whenever you see the question, first and foremost, you have to derive your hypothesis. The hypothesis is characterized in two parts, which is H0 and HA. Okay? Now, H0 and HA are complement of each other. It always begins with your population mean, your mu. Now, H0 is always more or equals to, less or equals to or equals. So, it's always 0 on the other side. So, if this is 0, this is less than 0. Okay? If your H0 is like this, then your HA will be its complement, which means it will be its opposite, which means it's more than 0. Now, after you have derived your hypothesis, now what you do is you look at your alternate hypothesis. So as you guys can see, your HA for here is mu less than 0, which means for this hypothesis, it's a left tail test. Your rejection region is less than 0. 0 is at the point here. It's at the peak. Here, with 0 being here. Since it's a right, because this points to this direction, it points to the right, so it's a right tail test, so your rejection region is over here. So when you wanna find out where your rejection region is, when you wanna know what kind of test it is, you look at the HA. Regardless of the claim, you still look at the HA. Okay? Next is the formula when you want to test a mean. Now the formula is given to be Z, which is equals to your sample mean minus your population mean over your standard deviation divided by your sample size. This is to find your Z, and this Z is either ZC or Z0, which is actually used interchangeably. You also need to find your Z, and you find your Z by knowing what your alpha is, 2%, 5%, sometimes even 10% or 1%, and then you look at your normal distribution table, otherwise known as your Z table, and you find out your Z value. Once you have your ZC and your Z, you are able to proceed with the question. So to illustrate whatever I've said, to make it more understandable, let's now do a question. So the heartbeat of a particular species of rat is normally distributed with a mean of 65 beats per minute and standard deviation of 10 beats per minute. A sample of 40 rats was exposed to air with lower than normal composition of carbon dioxide in it for a period of 1 week. The post-experiment result yields an average heartbeat rate of 60 beats per minute. Is there sufficient evidence at a 2% level that decreased carbon dioxide intake, which has caused their heartbeat rate to decrease? Now, by looking at the question first, let's get your variables out. So firstly, they say normal distributed with a mean of 65 beats per minute. So this is supposedly to be your mu. Okay, this here is your standard deviation. This is your sample size. So this is n equals to 40. This is SD. Alright. A post-experiment result yields an average heartbeat rate of 60 beats per minute. So this is sample mean. Evidence at the 2% level, which means alpha equals to 2%. Now we look at the hypothesis. Is there sufficient evidence at the 2% level that the decreased carbon dioxide intake has caused heartbeat rate to decrease? Okay, so let's get it. Always find your H0 and HA. Now, 2% level that the decreased carbon dioxide intake has caused heartbeat rate to decrease, which means let your mu be your heartbeat rate. And this one also, it says that heartbeat rate of a particular species of rat is normally distributed with a mean of 65 beats per minute, which means they're saying that your population mean is equals to your heartbeat rate. So heartbeat rate more less than 0, and this is your claim. This is what the question wants you to test. So to write your HA is the opposite, which is more than 0, equals to or more than 0. Now you have here. Now you have to know what kind of test it is. So this points to the left. So this is a left-tailed test. And your alpha equals to 2%, write it as 0.02, which is equals to 2%. Okay? Now that you know that, let's find the z value. Okay. Now, you know that your alpha equals to 0.02%. When you look at your normal distribution table, you will find that z is equals to negative 2.05. So here you found your z. Now you want to find the z naught. Let's put it in this color. Also, it's called zc. How are you going to do this? So z is sample mean minus population mean over standard deviation over your n. So your sample mean is equals to 60, population mean is 65, standard deviation right here is 10, your sample size is 40, which is equals to negative 3.16. So based on your calculations, you have found that z is equal to negative 2.05, and your zc, also known as the z naught, as I've said it from just now, is negative 3.16. What you do now is you draw a graph. Alright, and this right here is a 0. Now, first you always start with a z. Z is negative 2.05, so this area is z, negative 2.05. So everything that lies beyond z is the rejection region. Okay, rejection region. Now let's look at your ZC. ZC is negative 3.16, which is around here. You can just estimate. You do not have to do any accurate measurements. So this is ZC, negative 3.16. Now ZC lies in the rejection region. So what your conclusion is, as ZC, which is less than Z, ZC lies in the rejection region we reject H0. If it's not inside the rejection region, we do not reject H0, and if it's inside the rejection region, we reject H0. So if ZC is around here, we don't reject. But since ZC is here, it is in the rejection region, that's why we have to reject H0. We always reject H0, we don't reject HA or anything. HA is used to see what type of test it is, and H0 is basically to know whether you want to reject or accept H0. So since H0 is directly rejected, what is H0? So as we have done previously, this is the hypothesis we have come up with, and H0 is mu is more or equals to 0, and this, as we have calculated, we reject this, so we reject. If we reject H0, which means we support the claim. So thus, your conclusion is, at alpha equals to 0.02, and this is a level significance, there is sufficient evidence to support the claim. And yeah, blah 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 blah, basically what claim it is. So that's how you do it. Let's go through, okay? So your step 1 is, first you find your hypothesis. So you want to know whether to reject or not. After that, you have to know which is your claim. Your claim can either be H0 or H8. It really depends on the question. Once you have gotten your hypothesis, next what you have to do is you have to know whether it's a left tail or right tail test. There's also two tail tests, but I will cover that in other videos. But let's now focus on left tail and right tail. Once you have known that, you also need to know your level of significance, which is basically your alpha, and this is always given in the question at the 2% level. Next is you find the standardized test statistics, which is the Z and your Z naught. So Z is basically, you look at your level of significance, which is 2%, which is equals to 0.02, and you look at your standard, and you look at the normal distribution table and you arrive at negative 2.05. You don't have to do any calculations here, just look at the table and then the table will give you directly the value of z. Next is you find your z naught. Okay, you just use the formula given and then you will arrive at negative 3.16. Once you have these two, yay, it's like, it's so good already. You are able to make a statement. So you draw a graph, and once you have drawn a graph, you have to compare your z and your zc, which is their position. This zc, this value over here, and this value over here, they are known as critical values. So the critical value of z is negative 2.05 and critical value of zc is negative 3.16. Anything that is beyond z, not zc, is known as the rejection region, and if zc is in the rejection region, we reject h naught. If it's not in the rejection region, we do not reject h naught. We fail to reject h naught. So based on our hypothesis, since our h naught is not the claim, h is the claim, and we reject h naught, we accept the claim. But if, for instance, the claim is h naught and we reject h naught, which means we are rejecting the claim, and we write at alpha equals 0.02, there is insufficient evidence to support the claim, if our claim is h naught in this case. But since our claim is HA and we reject H naught, there is enough evidence. I hope I'm not confusing you guys. But if you do have any questions, please write down in the comments below. I will try to answer it to my abilities. You can also drop me an inbox, which most people have done so, asking me questions on chemistry or math. And if you enjoyed this video and you want more videos, please do request for it in the comments below, because sometimes I really do not have any idea what kind of videos I want to do, what kind of educational videos I want to do. And if you want to keep updated to all my future uploads, always remember to subscribe and share this video with your friends.